mean by perspective projection? So let us look at this. Put them one down. So let us look at this. Okay. So basically we have two types of projection. Projection means putting the object onto the screen. That is how I can simply put the definition of projection. So you have an object and the camera, take the camera, and there comes what do you mean by projectors. So camera lens will project it, and you can zoom in, zoom out. You can you can take 2D view, 3D view, whatever, and those outputs will now come on your screen. In other words, that image will now be projected onto the screen. Now the way it gets projected, it's of two types. One is called parallel projection, one is called perspective projection. Now in parallel projection, what do you mean by parallel? I will let you know in 1 minute. Now in parallel, there are two types, orthographic, oblique. By default, computer graphics system uses orthographic parallel projection. That is why you always do GL ortho 2D. Last class I talked about GL ortho, right? So in other words, projection out of two types. Parallel means it is artificial. Perspective means it is natural. So since computer is artificial, it always understands artificial projection. In artificial, it goes with orthographic parallel projection or orthographic artificial projection. Now, what do you mean by parallel projection? Now, you can see something like this. This is the viewing volume, this is a window, and this gets to the screen. Let me say parallel projection. Now, there is this AB viewpoint, and this is what you need to see now. And these are the projectors. Now, projectors are always parallel to the plane. Now, A dash B dash is what I see. AB is the object. A dash B dash is what I see in my screen. So the projectors are always parallel to each other. In other words, projectors are perpendicular to the plane. If they are perpendicular to the plane, then only I can say projectors are parallel. You can take this example. Yeah. Whatever you have done in your first sem, second semester computer graphics, your CAD lab, they are all part of your parallel projection. Now you remember this diagram. So you take your front face, top face, side view, and all. So these are the projectors. They are always parallel to each other. In one more way of putting this is, projector is perpendicular to the plane. In other words, projectors are parallel to each other. They never meet. So that is how you get this front face, or side view, or top view, or whatever. Now these are all artificial. Now orthographic. Now coming to this orthographic. Now parallel projection means projections are parallel to each other. Orthographic means if the projection rays, that is this, the projection rays are perpendicular to each other, perpendicular to the plane, that is called orthographic projection. If the projection rays are parallel, and if the projection rays are perpendicular to the plane, it is called orthographic parallel projection. One more way, one more type is if the projection rays are parallel and if the projection rays are not perpendicular, that is called oblique projection. Something like this. You can see here, this is not perpendicular to the plane, but still they are parallel. In that case, it is called oblique projection. Now, in the other way, in the other type, if the projection rays are not parallel at all, if they converge, that is called as perspective projection. Means perspective in the sense natural. Our eyes, we are in this perspective projection system. What do you mean by projection rays are not parallel? For example, look at this. This is my object, and this is how my A dash B dash. This is how my AB gets projected onto the screen. Now, if the projection rays, you can see here, they are not parallel, they will converge at some point. So this is our eye now, our human eye, center of convergence is something like this. So example is, you can say something like this. The farer objects looks very smaller. The nearer objects looks very bigger. Whereas in parallel, no matter where you see, the object remains same because it is artificial. Because the projection rays are parallel, they never coincide. It looks artificial. Either you see the object right now here, or if the object is at 1 kilometer away, the computer draws same way, the same thing. Whereas you can take this sun. Sun is a perspective projection. You know, sun is at one point, all the rays converge to the sun. So our eyes, human eyes, forms perspective projection. So whatever looks natural, that is your perspective projection. Whatever looks artificial, that is your parallel projection. Now in perspective projection, there is 1 point, 2 point, 3 point perspective projection. Means if all the projection rays converge to 1 point, it is called 1 point perspective projection. If all the projection rays converge to 2 point, it is called 2 point. For example, you can see this all these projection rays is converging here. It is called 1 point projection. Or all the projection rays are converging at sun. Now you can see something example like this. Yeah, 1 point projection. You can see all the projection rays are concentrated here, are converging here. This is more naturalistic. This is how our eyes perceive. Right? If you put this in parallel projection, you will not see this center of projection. You will not see this projection rays being, coincided with 1 point. You will see as if everything is parallel. So that which is artificial. This is 1 point projection. 2 point projection, you can see something like this. Yeah, this is 3 point. This is 2 point. So here is one point of projection, one center of projection, and here is one center of projection. So if you look at this, all the rays goes to this end, and all the rays goes and converges at this. So this is 2 point projection. So 3 point means there will be 3 points of center of projections, something like this. You can see left one, the top one, and the right one. So all the left rays projects to this right and the top. So that is how you will get 3 point projection. And if you look at a building from this angle, you will see left one, right one, and top one. Our eyes will somewhere, take all these projection rays and converge to some point. Or in other words, all these left, right, and top will be converged at their respective ends. So this is what you mean by 3 point projection. Now I will go to these concepts later in my theory class. Now whatever is required for my 4th lab program, I'm doing. So you can see types of parallel projection, orthographic and oblique. When the projection is perpendicular to the view plane, it is called parallel orthographic. When the projection is not perpendicular, that means it is parallel but not perpendicular, it is called oblique projection. You can see, so these projection rays are perpendicular, it is called orthographic. Projection rays, of course, they are parallel, but they are not perpendicular to the plane, it is called oblique. So all this comes in my theory class. You will see. This is what you have done in your CAD class, I believe. So you have taken an image, draw the front view, side view, and the top view. You can see, here. All the projection rays are parallel, but they are not perpendicular to the plane. So it is called oblique parallel projection. For example, in this case, some guys are perpendicular. But in a nutshell, everything, all the projection rays are parallel. This is how computer understands. This is what is used in, for example, if you construct a building, the architect comes and gives you the plan. So that's purely based on AutoCAD, and that is what they use, parallel projection. Nowadays, they come with 3D modeling. You will see a isometric projection, that is called 3D projection as well, something like this. Yeah. But again, they are all part of parallel projection. So this is what we can talk about various projections as such. And if you remember yesterday's program, this is the yesterday. As you can see, this is 3Q, and this one is 4th one. In the third program, what we did, I'll just recap. So these are my vertices. If you want me to show the PDF, I have here. Alright, this is my third one. If you remember yesterday's program, these are my vertices. I talked about how do you figure out the vertices. First, you should take 0, 3, 5, 6, and then the corresponding 4, 2, 7, and 6, or 1, whatever. And then colors and the cube indices. Please don't see this diagram. The diagram is this one. This diagram you can see, and we saw the anti-clockwise means visibility, clockwise means non-visibility. After this, my theta axis, display, draw elements. We talked extensively about draw elements. Without draw elements, what happens, all the stuff we talked. And then the spin cube whenever it is idle, and then the mouse, and then the reshape. That is what we discussed last class. So you remember reshape? We extensively talked about reshape. You remember this? Yeah, paint program, paint usage. All right. So all these we discussed yesterday. Now comes this is parallel projection. You can see here. I believe now your understanding will be strengthened. It uses, third program uses GL ortho. That is your parallel orthographic projection by default. Now we don't want ortho, we want perspective projection. That is your fourth program. You can see, draw a color cube and allow the user to move the camera suitably to experiment perspective viewing. So I have written in my manual 90% same as previous program, except this guy. Instead of GL ortho, we use GL frustum. What do you mean by frustum? You take one paper. You remember I had talked about this in the class. Take a paper, fold it like a cone. That is actually a cone. Cut the lower portion. It becomes the frustum. So you can view from the either end. So all the rays gets converged at one point. So that is why it is called perspective projection. That is theory. How do you put it in OpenGL? We have an API called GL frustum. Frustum also takes something similar to your GL ortho. GL ortho takes 6 parameters: LRBT, near far. Frustum also takes 6 parameters: LRBT, near far. The moment you write ortho, it understands that the projection rays are parallel. Who understands? OpenGL understands. The API understands. The moment you write GL frustum, API understands that the projection rays are not parallel. Hence, I should show the object as naturalistic as possible. This is the main difference between frustum and ortho. All right. So we'll come to this. As a customary note, I will show the program, the similarities, as we have done yesterday as well. Vertices, no need to explain. Yesterday, extensive discussion is done. Colors is same. You can change the colors. theta is same, axis is same. Yeah, this is the new concept, viewer. I am viewing from the Z, positive Z angle. My wish, you can change this. This is the initial viewer location. This line is the new line for the fourth program. And I am not using draw elements. Again, my wish. I thought, let me show the other way of draw elements. You remember before draw elements, I told about this, right? So instead of, to draw one face, I require one GL begin, 4 GL vertices, and 1 GL end, 6 lines. So 6 lines for one face. So totally we have 6 faces. So 6 into 6, 36 lines. So let me avoid that. Let me use floating point vector. You can see here GL polygon. Instead of writing GL vertex, GL vertex, GL vertex 4 times, what I'll do, I'll write once. I will use vector and I will show vertices of A. So vertices of A is, it is 0, 3. I will send ABCD from where, I think from here. So 0, 3, 2, 1 is what I call. So 0 is A, 3, B, 2, C, 1, D. So 0, 3, 2, 1 is what I call, and all those guys will come here, and I'll put it in vector vertices of A. So first vertex will be plotted. Now that means first vertex means that is the 0, 0, 0, 0. Next one, go ahead with 3, 2, ABC, D. And this is optional. This is just purely optional. That is, for every vertex, I am giving some color. I cannot say optional, but it would look good if you can interpolate all the colors. So how many lines now? So 8 plus 1 begin, 1 end. So 36 lines got converted to 10 lines. Now you can skip all these 10 lines and you can just copy paste that one line called draw elements, which we did in third program. I thought I'll show my students the vector way as well. So it is purely my wish. You can copy paste that one line called draw elements, put it here. Or you can copy paste the entire third program, just replace the GL ortho with GL first and suitable other subtle changes which we'll talk about. All right, this is the polygon stuff. And color cube, in there we had written as, here. You can see, the third program we had written draw elements, and this draw elements itself draws all those 6 faces of the polygon. Whereas here, one polygon's 4 points you should call like this, and that is one face. Like this, you need to call all the 6 faces. So all these can be clubbed into this one guy called draw elements. You can do that, no problem. All right. So next one, display, and these same guys will come 0, 3, 2, 1, 0, 4, 7, 3. You can see here 0, 3, 2, 1, 0, 4, 7, 3, 2, 3, 7, 6. All these guys same also. Now display also. Display is also same. Instead of draw elements, anyway, I would have drawn the, instead of draw elements, I would have drawn polygon, something like polygon color cube. So instead of draw elements, you call color cube. Color cube in turn calls polygon. Polygon means this function draws 4 vertices. Means one face is over. Anyway. So you can skip this GL flush. Anyway, we are using swap. So mouse function is same. You can see when compared to this mouse is same. And since I might as well copy spin cube function as well here. You can no problem. You can have a separate spin cube, and in the idle, because I don't have an idle func here, you can call idle func of spin cube. Not a problem. So that's what I told you. Third program, you can copy paste as such. Some 2 to 3 lines you can change. Instead of course, the main change is ortho to frustum. All right. So this I have explained already and called the display function. So this is new thing for you. Keys. And again, this is purely optional. VTO has never said to use keyboard. Why have I introduced keyboard is, in my third program, I have anyway taught you mouse interaction. This program, if I teach you keyboard interaction, this will help you in your mini projects, because mini projects is a nice application wherein you will use definitely mouse or the keyboard, or perhaps both. You will interact with the user. So if from that perspective, I have taught you how do you use keyboard. So if you want to use keyboard, you should make sure you have written this guy, that keyboard func of keys. So keys is again a function name. So go to here, it has 3 parameters. If the key is equal to, if you press X, what needs to be happen, what needs to do, if capital X, what needs to do, all the stuff. We will discuss in a while. I'm just showing the difference between third and fourth. So this is entirely new. And coming to this, my reshape, copy paste my reshape, and instead of ortho, just write custom. And now coming to the main part. So this is the essential difference between third and fourth. Now it is our job to look at fourth program line by line. All right. So come from the beginning. Vertices is done, same concept. Colors is also done, same concept when compared to third program. These two same, and this is my viewer location. Right. That is, I am viewing at z-axis. And understand, guys, 3D object can be very well viewed if you look at, if you stand in z-axis, either positive or negative. That's how 3D guys look well. All right, we'll come to those functions later. Now come to the main. All right, so this is initialization. Since it's a 3D animation, I use double, and I should enable the depth as well. This is my window size. All right, now let me first talk about display. So go to display. In display, all these are done yesterday. The initial diagram. This one, yeah, this is also a bit different. Yeah, this is also a new line, because it is a perspective projection. I should show where exactly my viewer is, or where exactly my camera is. And understand, look at, as we have already seen in my teapot program. So look at has 9 parameters. You can see here. IX, up X, up Y, upset. You can see, yeah. Here. IX, IY, IZ, center X, center Y, center Z, and up X, up Y, up Z. So this is a new line, because this is where, I mean, my center of projection should converge, as we have seen in the perspective projection. But the point is, where exactly, what exactly is your location? Because for the projection rays to converge, it should know where exactly the viewer is, or the camera is. So that is this position. So viewer 0, viewer 1, viewer 2, I think all are, yeah, viewer 0 is 0, viewer 1 is 0, viewer 2 is 5. And yeah, you can see here IX, IY, IZ, and center X, center Y, center Z, all these are all these are 0. Purely my wish, you can change all this, up X, up Y, up Z. So by the way, if you have written like this, and this is how your output. I have not talked about output yet. Now I'll talk about. Now please look here. By the moment you run this program, you will see a still image. Why? Because I have not taken any my mouse or keyboards into consideration. Now you can press left click, and since we don't have an idle function, like third program. The moment you do one left click, it just rotates and it keeps going because there is no idle function. Because the customer is idle, program is also idle. Yesterday program we discussed this. When the customer is idle, program should not be idle. That is the reason you have written what is that, glut idle func of spin cube. So here we don't have idle func. We can write it, no problem. But I'm showing the other way as well. If you right click, it rotates via Z. If you middle click, if you rotates via, it will rotate via y-axis. Now there is one more extension called keyboard. Now look here, please. This is where perspective projection really comes into picture. Now perspective projection means natural projection. Now please look here. If I press small x, my caps lock is off. If I press small x, you can see the object goes. It is like now your 1 point projection. It is going far away. As the object goes far away, object looks very smaller. For example, let us say in front of you there is your brother, and you can see a larger depiction of your brother. Now, if your brother goes far away from you, this is how your brother looks very smaller and smaller. And on the other hand, caps lock is on. Now you press X, capital X. So now your brother is coming in front of you now. Caps lock is off. Small x means brother is going off, going away from you. And caps lock is on. Capital X, I mean. So keep pressing capital X. So your bro will come nearer to you. Now, again, this is X way. Now, caps lock is off. Press small y. Your bro will now rotate, will now transform via y-axis now. Again, small y means he goes away via y-axis. Capital Y, he comes nearer to you via y-axis. That means he keeps on rotating and he keeps on coming to you via y-axis. Now, caps lock is off. Small z, press small z. This is what happens. Caps lock is on. Press small z. You can change the behavior. You can press any key. You should write the code here. Here. You can see. This is small x means viewer 0 minus equal to 10 means if I press any doubt. No, all right. You can see here. Yeah. If I press small x, viewer of 0 means x-axis is equal to this one. Minus is equal to 1 means go far away. For example, if I press small x, go far away. If I press capital X, come nearer to you. So that is this minus and plus plays a big role. And small z, minus and plus. Similarly, you can add any key, and you can. This is something like this. In your Java, you have the action and action event, right? So if this is your action, and this should be my event. So if you press small x, this is my action. If you press capital X, this should be my action. You can interchange this. You can write whatever action you want. So this program talks about interacts with mouse and interacts with keyboard. Something like this. All right. This is your perspective. That means I'm showing my object in real time, natural. That is what I mean. So center of projection definitely meets. He can come near. He can go far away. He can come nearer to you. All these happen. The moment he comes nearer to you, the object becomes bigger and bigger. The moment he goes far away from you, the object goes smaller and smaller. This wouldn't have this is not the case with the third program. In the third program, no matter which axis you rotate, the entire output remains same. X-axis, Y-axis, Z-axis, no matter you are here or far away, the object, the output remains same because it is artificial. Whereas this guy is natural. Natural. How we can accomplish naturalness is perspective projection, and the answer is you should use frustum. And of course, you're in the display, you should use your camera position. That is your this. See, look at is your camera position. You take a thread, hang your camera, and nail it. So this guy, when you nail the camera, when you hang the camera, IX, IY, IZ is your eyes. That is from your view. Where is the camera at X way and Y way and Z way. And next is center X, center Y, center Z. From the projection plane is considered where exactly the camera is. Up X, up Y, up Z. Vertical way. Up X, up Y, up Z. That is vertical way where exactly the camera is being hanged. Now this is the new line when compared to the when compared to the third program. These are all we have seen. Rotate, floating point, theta of 0. Theta of 0. Right now all are 0, 0, 0. We will increment it. So that means rotate. What is this? Rotate the object by 0 degree. Okay. So now we can see here 1, 0, 0 means x-axis way. So same concept. I will write here. Rotate the object 0 degree y-axis, and similarly by z-axis. Initially, you are rotating by 0, 0, 0 degree, and now you are calling color cube. Color cube means go here, call polygon 0, 3, 2, 1. We have discussed this extensively. Yeah, here 0, 3, 2, 1. This is the face which I see. That's the reason I have. Please don't write 0, 1, 2, 3. That means that particular face will not be visible. So 0, 3, 2, 1. So polygon function, you will go to polygon. So this gets called as 0, 3, 2, 1. So now begin polygon. Color 3 floating point vector colors of, now it is colors of A. What is A? 0. Colors of 0. Now colors of 0, put it in vector form. That is this guy, entire these days. That means 0. Next one, vertices of A. So it will now become vertices. This is pure C language. Vertices of A. A is again 0. So vertices of 0 means this guy. -1, -1, -1. So begin that with this vertex, and vertices B, vertices C, vertices D. For every vertex, I am giving a new color. How did we do this in third program? Okay, look here. Interesting question. Look here. So in the main function, the last lines, you can see here, after enabling the vertex arrays and color arrays, what I am doing, for every 3 vertices, you give colors. For every 3 vertex, you give that one color. One color, see, one vertex is made up of 3 guys, that is X, Y, Z. One color is made up of 3 guys, that is RGB. So for every vertex, you give one color. That is how I am putting in third program. Whereas in fourth, in polygon itself, for every vertex of 3 guys. Means it is what? X comma y comma z. For every x comma y comma z, you give me r comma g comma b. Red, green, same thing. Whatever we discussed here. For every vertex, you give RGB. Similarly, for every vertex of x, y, z, you give RGB color. So this will now happen for 4 vertices. That is 0, 3, 2, 1. Means it is one face of the polygon. One face of the polygon having 4 vertices. Alright, like this. Like this. This is one face. This is the second face. Second face. Like this. 6 faces. 6 faces means 6 times you call. So every face has 4 vertices. So you are essentially drawing a polygon. So how many lines in fact? If you can, line by line, if you can calculate, color cube is 1 line. It goes to this guy. Color cube is again polygon calling one line, and one polygon has these many lines. So if you can count, essentially you will get this is 8 plus 10 plus 2 flower brackets 12. This is 13. This is 14 plus 6, 20 plus 2 flower brackets 22 plus 1 color cube. 23 lines has been now clubbed to 1 line where draw elements. So this is the power of your draw elements. And the point is, whenever you use draw elements, you should tell me the color pointer and vertex pointer and the states. So these 4 lines. In my 4th program, those 4 lines are not there. You can see that in the main program, that means these guys are not here. Why? Because I have put it in my polygon function itself. All right. So yeah, that is the power of your draw elements. You can write that as well here in this program as well. All right. So basically, we are in display func of display. In display, we are done with all these. We are done with color cube. We can skip this guy and swap purpose. All right. So that is your display. Now coming to reshape quickly. So reshape. So 6 to 7 lines. Similar. These guys. Same. All the lines are same except frustum. And yeah, to talk about this, you should remember this. Whenever you reshape via horizontally or vertically, if you reshape via horizontally, left and right changes. So left and right changes means the width gets changed. So which is smaller value. So width is having higher value, height is having smaller value. So smaller value is height, so you should put height here, and the other one is width. So it is W by H. So that is why you should write, whenever the width is more, you should write W by H. So whenever width is less than height, means, you remember that diagram, this diagram. So you have this one, and you increase this is your height and this is your width. So height is more, width is less. So this condition, width is less than height. Of course, width is less than height. Width means you can consider 2 centimeters here, and height is you can consider 10 centimeters here. Width less than height. That is this condition. Width is less than or equal to height. Obviously, width is 2 less than 10. So which is the smaller value? Width. That is how we should write width here, and the other guy is height. This is how it becomes h by w. So this is how it is h by w, h by w, and the other guy is w by h. And same concept. If width is less than height, in this case only my, you remember this also we had shown. This is your left, right, and this is your bottom. This is your top. So only B and T, bottom and top, changes. That is why I have written, you can see this is LRBT near far. So in this case, bottom and top, this case bottom and top changes. So bottom, you do maintain the aspect ratio, and top also maintain the aspect ratio. Other guys remain same. Whereas in the opposite case, LR, okay, there's some problem here. Yeah, there is this. Yeah, you can change this because it is frustum. Doesn't matter. Frustum, because it is frustum. Because anyway, a center of projection goes with 1 point or 2 point. You can change with bottom top as well. Anyway, I'll clarify this. You cannot take this into granted. I'll clarify this in the next class. And model view. After you rotate, model. This one I'll clarify. This why it is. So that is your reshape. So reshape is now displaced on mouse. Mouse, same concept. All this. If you press left button, press down, axis is 0. Middle button is 1, 2, and this is your spin cube function, which we had written in the third program. So every time you rotate, change from 2 degrees, and whenever it crosses 360, make sure you're nullifying the effect. Minus is equal to 360. So the moment it becomes 362 degrees, you're actually making 362 degree minus 360, that is 2 degrees. So I'll display again. You can write glut post redisplay as well. Next is keyboard function, keyboard of piece, which I have already taught. This is your event, this is your action, and enable the depth test and call the main. Enable the 3D depth, call the main. So this essentially completes perspective projection and the implementation of this. Any doubts? If you have any doubts, please put it here. And now I will stop the recording. I'll start the recording again so that you will have a recording session only for attendance purpose. So this I will stop now.